Good morning, doctor. My name is Lee Chen Yet, and our team is Royal Gold. Our presentation topic is RBI for piping system. Introduction to RBI. Risk-based inspection is a systematic approach used in managing plant equipment and facilities to prioritize inspection effort based on risk. The core of RBI lies in evaluating both the probability of failure and the consequences of failure to get the risk level for static equipment. Doing so allows companies to allocate resources more efficiently, ensuring that high-risk areas receive more maintenance effort instead of wasting on low-risk area. This not only enhances the overall safety and reliability of the plant, but also leads to cost savings by avoiding unnecessary works and times. This is the figure that shows the process workflow of conducting risk-based inspection, which could be lengthy, but we can roughly separate it into three phases that will be discussed in the following. The first phase of risk-based inspection is data collection and verification. Data collection and verification involve gathering critical information for the RBI study, including static equipments, design, operation, inspection, and maintenance data from General Assembly GA drawing and piping and instrumentation diagram PMID. The second phase involves conducting a risk assessment to obtain the risk profile for equipment, the probability of failure POF, and the consequence of failure COF needs to be evaluated. The POF assessment focuses on determining the likelihood of a failure event occurring due to internal and external damage mechanisms from corrosion. Conversely, the COF consequence of failure assessment look at the impacts of equipment failure on these four elements, which are people, concerned about the safety impacts on workers, asset, concerned about the economical loss, environment, concerned about the environment damage, and lastly, reputation, concerned about the public image of the company. The risk is typically a product of the probability of failure POF and the consequence of failure COF. RBI risk analysis results are categorized into one of four risk categories in the risk matrix, from low to very high, differentiated by color. Then, a corresponding inspection plan will be assigned based on the equipment's type and risk. The third phase of RBI is inspection planning and execution. Once the risk assessment is completed, this step involves developing a detailed plan for inspecting the equipment and executing the planned inspections. The Inspection Reference Planning (IRP) defines the coverage of inspection, the inspection techniques, and the inspection intervals. High-risk items are prioritized for more frequent, while lower-risk items may undergo fewer intensive checks, reducing unnecessary downtime and costs. During the execution phase, inspectors collect data related to the condition of the equipment through the selected inspection techniques. This data encompasses observations, measurements, entity results, and other relevant information. Moving on to the next slide.
Next, let us take a look at the standard use, which include the regulatory requirements, guidelines, and standards. First, let us take a look at the regulatory requirement. In Malaysia, there is no specific regulatory requirement for RBI. However, DOSH has offered a program called Special Scheme Inspection, which is equivalent to RBI. This program will help company to transition from time-based inspection to risk-based inspection. It also promote the enhancement of safety culture and reduce the likelihood of safety audit by DOSH. Next, let's take a look on the guideline of RBI. There are three major guidelines, which is American Petroleum Institute Recommended Practice, short for API-RP, 580, 581, and 582. In API-RP 580, it outlays the overall process of RBI, from data collections to risk assessment to risk ranking to inspection planning. The risk is equals to probability of failure times the consequence of failure, short for POF and COF. The probability of failure is discussed in details in API-RP 581. It outlays an equation which is PFT, probability of failure, equals to GFF, which is generic failure frequency, times the FMS, which is the management system factor, times the DFT, which is the damage factor as a function of time. The guideline established rules on how to get this value. The third guideline is API-RP 582, which focus on the consequence of failure, which with emphasis on personnel safety, environmental impact, production impact, and property damage. It uses both a qualitative and quantitative approaches. Lastly, let's take a look at the company-specific standards, specifically on the Petronas RBI, also known as PRBI. It started off with data collection and moved on to calculating the POF. The POF is determined based on the corrosion factors and can be calculated based on the environment condition and the age on the second table below. Next, it moved on to calculating consequence of failure, ranking between 1 to 5 from minor to catastrophic. It put consideration on the production, environment, asset, and reputations. After getting the POF and COF value, the risk is ranked accordingly to P1 to P4. P1 is the highest ranking risk, which stands for priority 1, and P4 is the lowest ranking risk, which stands for priority 4. After that, the recommended action is suggested, such as to be repaired, to be rectified, to be painted, to be maintained, or to strip off, according to the table shown below. Lastly, based on the risk ranking, the criteria, and the equipment, the guideline also outlay the appropriate inspection planning and inspection interval. It gives a suggested inspection interval, which acts as a reference point when carrying out maintenance or turnaround.
A very good day to Doctor. This is Liao Jiahao presenting the risks involved in piping system. The first risk is corrosion. It is a gradual deterioration of a material, which is usually metal, and it is caused by the chemical reaction with its environment. Corrosion can weaken the piping materials, leading to leaks or ruptures. Second risk is internal erosion. Fluid flow can cause erosion and wear inside pipes, which may reduce the wall thickness and structural integrity. The third risk, which is the high temperature. Elevated temperature and pressures can accelerate degradation processes such as creep, fatigue, and thermal expansion, which will increase the risk of failure. So, how can we manage this risk? Towards the risk of corrosion, we can implement the corrosion monitoring techniques such as regular thickness measurements and corrosion rate calculations. Regarding the internal erosion, we can use flow modifiers such as flow restrictors or baffles. Baffles controls flow velocity and redirect the abrasives, damping vibrations, and protect vulnerable areas. The third one, which is the thermal stress analysis, this is to implement thermal analysis, use insulation to regulate the temperature, and conduct stress testing under operating condition to ensure the temperature is within control.
Good morning, Doctor. My name is Steven, and I will be explaining about the inspection plans of RBI in piping system. An inspection plan is critical to prioritize the inspection efforts based on the potential risks and impacts of failures. This approach allows for a more efficient allocation of resources by focusing on areas that pose the highest risk to the piping system integrity and safety. Now, we will look at the inspection confidence category for different damage mechanisms in piping in Petronas risk-based inspection plan. So, the inspection method for each damage modes are outlined and categorized into different confidence levels, including low, medium, high, and very high category to determine the extent of inspection. For example, we look at the internal thinning due to general corrosion, which can be inspected using thickness measurement tools. The inspection confidence levels determine the extent of coverage. For example, for low and medium confidence, less than 25% of internal corrosion are inspected. As the confidence level increases to high, 50% of the internal locations are inspected, ensuring all critical areas are included. Next, we look at the PRBI inspection strategy for internal thinning damage due to general corrosion. From the table, we can see that when the risk rating is very high, the inspection priority is also very high with a number of less than 6. Then the inspection extent is larger, which means that 50% of potential locations are needed to be inspected. And then the inspection interval is also very short of 5 months. But when the risk rating is very low, the inspection priority is also very low with a number of larger than 15. Then the inspection extent is also smaller, which means that only 5% of the potential locations need to be inspected. Then the inspection interval for low risk rating is also longer, meaning that the inspection need to carry out for every 15 months only.
Hi, my name is Chang Junyang and I'm going to present the case study part. Let's look at our first case study on implementing RBI in a refinery piping system. The refinery experienced frequent unplanned shutdowns due to piping failures. To address this, they implemented an RBI program to improve reliability and safety. They collected comprehensive data including design, operation, and maintenance record. The risk assessment identified corrosions, fatigue, and external damage as primary failure mechanisms, evaluating both probability of failure (POF) and the consequence of failure (COF). Based on this, they developed an inspection plan prioritizing high-risk segments for ultrasonic testing every 6 months and low-risk segment biennially. Initial inspection revealed significant corrosions, leading to timely repairs or replacement. This proactive approach resulted in fewer shutdowns and reduced maintenance costs. Next, we examine RBI in offshore oil platform pipelines. The platform faced integrity issues due to harsh conditions such as high salinity, pressure, and temperature. Due to optimized inspection and improved safety, they implemented an RBI approach. They collected data on pipeline design, material, and operating conditions, reviewing past inspection results and failure modes. The risk assessment considered POF and COF, focusing on corrosion rates, mechanical stress, and environmental impact. The inspection plan prioritized high-risk pipelines for advanced techniques like magnetic flux leakage and guided wave ultrasonic testing, with high-risk segment inspected annually and lower-risk segments every 3 years. Initial inspection detected significant corrosions and potential cracks, prompting immediate repairs and the use of corrosion inhibitors, which significantly reduced pipelines failures and environmental incidents.